Oh, okay. So thanks for everybody for coming today. I know that there's a few people that can't make it, no problem. Today, what we're going to do is Rahul is going to actually be walking you through an agent that he has created. And again, it is raw, it's preliminary, but what all the different questions around, agentic AI versus say chatbot AI, what's the difference between them? We thought it would be very topical to kind of, give you a look of what the difference is with something that Rahul has actually built himself. Be patient through it because this is, a demo and how demos go. Sometimes, there's still little things that need to be, dealt with on the fly. So with that, I'm going to turn it over to Rahul and he's going to take it from here. All yours, Rahul.
Good. Thank you, John. Welcome, everybody. Good afternoon. I hope your Friday is going well so far. What I'm going to show you today is the agentic structure that I've built. So I have been involved with fraud management and cybersecurity for a number of years. I am interested in the AI space. So I've been experimenting with some of the AI tools. And this idea occurred to me that why not we build something that can offload some of the tasks from an operations perspective. So I kind of experimented with a few tools, looked if I can leverage AI and the different LLMs to build something that can be useful from that standpoint. So as John said, still I am working at it, but it is at a stage where we can take a look and see how the agentic part of AI is functioning. And of course, if you guys have any suggestions for me, if you want me to make any improvements, I would love to hear that. And any questions, we can take them as well. So with that said, I'm going to turn off my camera. I'm going to start sharing my screen and we'll go from there. I'm going to first explain what we are seeing. You will see a lot of code to begin with, and then we will see a raw UI that I built for display purposes. So let me do that. Okay, can everybody see my screen?
Yep, we got it.
A lot of code, right?
Yep, ton of code.
Okay. So this is the VS Code interface I'm using to build this project. What this is about, it's about fraud. So what I've done here is that I have built a few agents. So this is a lot of Python code. I'll try to explain it at a very, very high level. And then maybe we can do another session to do a deep dive if anyone is interested. So what I did is I have created a few agents. You can see them here. One is called a high analyst, low analyst, medium analyst, orchestrator, and reviewer. What it means is that when, let's say, in case of a fraud situation, there are fraud controls that collect some data, some intelligence. All of that data is sent to a central location in an ideal world, and it is enriched with some other pieces of information, which we call client enrichment data. So we get some fraud signals, we bring it in, we have some client data already with the financial institution. We enrich the signals with that data is that it receives the incoming fraud signals. So it receives all the signals, it categorizes the signals based on the severity. So that is an attribute that we get from a data standpoint. Sorry about that. That's an attribute that we get from a data standpoint. And then this agent is looking at low severity, high severity, medium severity alerts, and then it is routing those alerts or those fraud signals to the agent, high analyst or low analyst or medium analyst to work it. I'm importing some files here which are required for Python code. This is my API key, which is essentially the password to connect to OpenAI. And then I'm providing some prompt to this orchestrator agent so that it understands what is the job that it needs to do, right?
So
And
Rahul, just a question. So when you started off by saying this is Visual Studio is a Microsoft product, or what is that?
it's a coding interface. So I use it's called VS Code
Okay.
to do the Python coding, but you can directly code in Python. There are some people use Anaconda libraries to code in Python. It's just an interface where you can write some code.
So it's a way to be able to write Python code, and you're using ultimately
Yes.
Python
Yeah.
code to kind of do this logic or coordination. Okay, thanks.
Yeah. Yeah. And there are
But
several available, I would say, interfaces where you can code Python. You can even code it on WordPad and save it as a PY file.
now, did you say you're using OpenAI, like ChatGPT as the brain, or how does that work?
Yeah. So essentially I'm using OpenAI and I'm using
Mhm.
Anthropic, a combination of. At some
Nice.
point I was using Gemini, but I dropped that based on the results that I was seeing. But I'm using predominantly these two, OpenAI and Anthropic
Claude, like Claude Opus or whatever, right? Okay,
Yes, yes.
thanks.
And we will see that.
Yeah.
So this is all some code. It kind of describes what the alert is, what the messages are, and all of that stuff. Right here, I'm saying that for this orchestrator agent, use GPT 5.1. Earlier, I was using GPT 4.0 for development purposes to save some credits or some money because the higher the model, the more tokens it uses because of its reasoning capabilities and other stuff. So I changed it to 5.1 for this demonstration. And then I'm telling it how many tokens it should use. Temperature is a setting that is available in some models. It is not available in all the models now because they have kind of deprecated that. It just tells the agent to be deterministic and not get creative in its responses. So here I've set the temperature to 0, meaning that stick to the facts, like don't invent anything because for this purpose and for this orchestrator agent, we don't need to come up with any creative solution. It just simply needs to ingest the input fraud signals or the alerts, and then based on the alert category, route it to a low, medium, or high analyst.
So
So
Rahul,
that's
are
what
you
it is
using
doing.
these directly through like an API call, or are you going through Microsoft to get to Opus and Like how does this kind of connect to those?
So
'Cause
so
these
this
people, a
is
lot of people are used to using chat windows, right? But this isn't a chat. You're like using an API call or something like that, or how does that work?
Yes. Yeah. So I'm using an API call, and where all of this is going, it's going into Microsoft. So I
Okay.
used Microsoft Azure to
Hmm.
host all of my resources. So resources
Oh, okay.
meaning all of these files, the data associated behind the scenes, and also calling the models. It is all being done through the Azure system or the Azure platform, if you will. And I have created resource groups in Azure. So a resource
Okay.
group is like a collection of resources, which would be your database, your app server, networking, and all of that infrastructure is handled through the Azure portal.
Great. I think Ellis has a question. Ellis?
Yeah, I would like to see, Rahul, if you can explain more, especially for the new people on the call. It's like, in the same regards that Jonathan was saying, like, I've seen that you can connect these open models, like even in WhatsApp, in many applications. In your case, you're applying that in your agents. But
Yeah.
could you explain more, like, how exactly is that a public API? How do you set it up for the first time? And if you want to customize it for an internal application, how do you access and consume those credits that you were talking about, like the OpenAI interface, the API? If you can talk more about it, I will highly appreciate it because I'm interested on that, but I don't know how, to do that for a person who like have that limited knowledge. What would be the right approach for us to know how to connect to that API, consume it, and set it up properly so we can, do something similar to what you're showing us on the screen?
Sure. So I think Thomas, right?
Ellis.
Alice, sorry, Alice. So we can have a separate session for that, but at a high level, what I have experimented with is OpenClaw. So OpenClaw is publicly available. It's a piece of software, if you will, right? And you can connect your OpenClaw. So you download it as a package from GitHub, and you can install it on your system, desktop or PC, whatever have you. And then you can connect your OpenClaw with any of the LLMs using the API. And you can also connect it or give it permissions to connect to WhatsApp or your messages, whichever platform you use for messages. I have used WhatsApp and I have used Discord in the past. And then you can kind of send a message through Discord. It kind of receives the message and then it does whatever you want it to say behind the scenes. So it is just like you're kind of changing the front end, but the back end mostly remains the same. So right now, what I have done for these agents is that I have written Python code. So instead of Python code, you're just using OpenClaw code and their libraries to do pretty much the same function. I can go through that maybe in one of the future sessions. I actually built something with Discord.
So I think Ellis, I posted a YouTube video that's a really good kind of like, ad hoc. Think of OpenClaw as a wrapper. It's kind of like what they call a harness. So that harness allows you to be able to connect to lots of different things. So he's using OpenClaw over top of, the main core stuff he's reaching out to is Microsoft Azure. So the infrastructure, like the hardware that's running stuff and whatnot, is on Microsoft Azure. And then through that, he's also connecting to OpenAI and Claude and ChatGPT, all that kind of stuff. So there's kind of layers to it. I just posted a video in the YouTube. So I think because we're about, our 50 minutes in, let's keep going so you can get to the UI, Rahul, and then we can do another deeper dive session on the layer cake kind of that he's
Yeah,
kind of
yeah,
asking about. Cool. Okay, go
yeah.
ahead.
So this is the orchestrator just using 5.1, and then it is going through the processing, and it will process to one of those agents. Now this is a high agent. For this high agent, I'm using GPT 5.4. Now we've got 5.5 as well. I am not using that. It uses a lot of tokens. And then earlier I was using actually Opus 4.8. And I kind of actually ran out of some time limit or something. So I kind of switched to 5.4. So for high, I'm using 5.4. And then it again has some logic in it in terms of it needs to process the information, the alerts that are coming in, and then it has to provide the response in a JSON format that we can display and so on and so forth. But the core here is that we are using this model, we are passing the information to the model and receiving the score back. One thing that you would see is that I have the max tokens here set to 3000 because the higher reasoning model we choose, the more processing power it needs. So for 4.0, it was, I think, around 1000. For 5.4, I kept it at 3000. If we don't do this, then two things might happen. Either you will get a truncated response, and in most cases, you will get an error because the response cannot be processed holistically by the JSON file. So that's high. For medium, what I'm doing here is still using GPT 4.0. So that's a lower reasoning model. And then for the low analyst, I'm using 4.0 mini. So even a lower reasoning model. And we can make that change. Like, let's say, if you still believe that for a medium level of alert or a medium severity alert, we need to process it using a higher reasoning model, we can do that as well. Like that all can be changed. So orchestrator receives the alerts, all the alerts incoming from the prod signals. It routes the alerts based on the alert severity to these agents, which are high, medium, low. And then these agents do their processing. So they review the alert, they create the disposition, they tell what is happening and what we need to do, which we will see in a sec. And then this reviewer agent reviews everything that all the other agents are doing. So it's like a final check before we provide a response to the executives or to whoever the response needs to go to. And then this reviewer agent, we are using Claude here or Anthropic here. So
And
the
why, Rahul,
model,
do you use why are you using different models? Are you just getting better results with the different, like you tested them out yourself, or?
yeah. So the reason I'm using different models is twofold. One, sometimes for a task which is pretty straightforward, for example, the orchestrator agent, it just needs to ingest information, do some processing, like apply some rules, and then route the alerts to other people or to other agents, right? So it
Okay.
doesn't need to be creative in its thinking. It can do the job with less processing or computing power. If I were to
So
employ, let's say, a Opus or other high reasoning model, then it would
yeah.
be like I'm kind of trying to give it more computing power than it needs. It's like you don't really need that much of power to do that job. So that's
Okay.
one. The other reason
So
is
like simpler
money.
type tasks, you use kind of
Yeah.
a certain model for, or a lower model because it saves on tokens and costs, and it still does just the same quality kind of thing.
Yes, absolutely. And
Yeah.
then the other thing is cost, right? So it's money.
Yeah.
So if I were to use a higher reasoning model, it's still going to show me the same results because it's
Mm.
doing a much simpler thing, but you will be spending more money doing the same job.
Yeah. So like it's kind of like, why pay somebody $100,000 to do a job that somebody you can pay $50,000 to do and get the same result?
Yeah.
Like
And then
in a
I applied the same
humanistic way,
logic.
right?
Yep, absolutely. And I applied the same logic here. So I said, if the alert severity is low, then I'm using Claude Sonnet to review that. But if it's medium or
Okay.
high, I'm using Opus. So I'm doing
Right.
that in the reviewer as well, just to kind of save on some cost and save on some compute because a low alert can be reviewed by a lower reasoning model. It doesn't really need the latest and greatest, and
Mhm.
it's okay. And for the other alerts, I'm using the best available.
And you probably tested this out with different models, right? To see which one applies
Yes, I
best for
did.
the
Yeah.
use case. Okay.
Yeah.
Yeah. So that's a key thing, guys, is that understanding that, like, it's not, you can't, if you just pick the highest one, it's going to cost you an arm and a leg, and it might be just, you could use a lower one and save yourself some dollars, but also compute time, right, Rahul? Wouldn't the lower Sonnet one be faster than Opus, or does that matter in this situation? Are they all about the same
No, it matters.
response?
So the high
Yeah.
reasoning model, of course, is taking more time because it's thinking more, it's trying to analyze more. So it's more time, more money, and pretty much the same result.
Okay, cool.
So that's it on a high level. And I know we are kind of short in time, so we can do a deep dive another day. But now I'm going to run the demo file. So for that, I use Streamlit. Again, it's a feature available in Python. And with that, it will open like a browser window where we will see a dashboard, and then we can select the alerts that we run. The other way to do this, which we can do at the end, is I run all the alerts in this terminal, and it'll just run everything and then give me the scores. So,
Okay.
but first we will go to the UI, and then we can come back to the terminal.
Yeah.
So, can you see my other screens?
No, we can only see the code one right now, the Python or the VS.
So it opened up another screen. Can I share my entire screen? Okay, so as soon as I ran that code,
Yep,
it opened up this dashboard.
Yep.
We can
Got
see
it.
it again. Let's do this
Yep.
again. So I'm stopping it right now. So it gave me this error. I'm going to close it, and I'm going to go here. I'm going to run it again, and then it's going to automatically open up this UI. It's running locally on my system,
Yep.
so you see this local hosted. So this is the
Yep.
dashboard that we have built.
Okay.
It shows the alert details. So right now I can do the filter. So I can filter all the high alerts, and I will see all the high alerts here. I
Right.
can filter by medium alerts. It will show me all the medium alerts. This information here is coming from the data file, which receives the original fraud alerts. So let's say I want to do this manually. So I can say, I want to run the high alert, and I want to run alert this one. And then I run this pipeline. You can see this agent activity. So the orchestrator agent is saying, route this to the high analyst, which is the right thing to do because this is a high alert and it should be handled by the high analyst. So it got routed correctly. Now the high analyst agent is working on this. It's right now pulling the data from whatever information the orchestrator agent has, whatever data we have in our data file, it's reading all of that information, and then it's applying the rules and the logic to process that information. It is also right now making an API call to the LLM in order to get the response from the LLM. So if everything
So in
runs
this case,
fine,
it's calling Opus because it's the high and getting
yeah,
back some of the details, essentially, kind of thing.
yeah,
Or
some of the details and then what to do. So yeah, we got the details back. So see, it says, okay, analysis is complete. It quickly sent it to the reviewer agent. The reviewer agent validated the decision, like whatever the high analyst agent said. And it said, yeah, I validated the decision and the decision is approved. And we are also, because we have to comply with OSPI guidelines. So in the code, I have built in OSPI compliance guidelines that whenever there is an alert, these are the things that we need to check in order to be OSPI compliant. So it does that as well. This information is coming from the LLM. So it's a confirmed fraud based on the attributes that were there in the fraud alert or the fraud signal. And it's saying that this is an immediate, urgent thing to do. What the agent or what I would say the operations team would do is they should freeze this account, they should block the transaction, they should contact the customers, and then they should notify the fraud management team, and a human should review this. So this tells you that it's important to have a human in the loop for anything which is of critical or severe nature. I also, because
I love that you've got the tokens used and the actual
yeah,
cost for this transaction. This costs 4 cents,
yes,
right? Like,
yeah, essentially, and I did that for my own purpose because I didn't want
yeah,
to
yeah,
run out of like my own tokens. But
yeah,
this is
yeah, yeah,
useful. So
yeah.
ideally, let's say a human, if I were to review this, I would take at least 5 minutes to go through all the information and say this or that. But in this case, this agent did it in 46.6 seconds. It used these many tokens and it cost us 4 cents. And we would
So
be,
4 cents versus 5 minutes of an average person's time is a huge savings.
yeah. And then I also built like a KPI dashboard. So it will say, what are the attributes here? and then some alert history. So I'll show you an example for a low agent as well, because in case of a low agent, I'm like the way I have written the code, it does it automatically. So it does not, or it should not say that a human needs to review this. It should just
Right.
say, this is what I arrived at and should be good. So let's choose a low severity alert and then run that again. Right now, I'm running it individually because we are in this UI. But if I go back to the terminal, I can run all the alerts at the same time. And then it'll give me like an executive summary there as well. That is the part that I'm still working on, where I can kind of take that executive summary and bring it in. So so I ran the alert. One thing we noticed is that this was much quicker than the high. See, it's 15.9 seconds as opposed to 44 seconds. That is again based on what you were saying, John, that a lower reasoning model would take
Haiku.
less
Yeah.
time, less tokens, and it would be faster.
Well, and you see the cost there, costs 1.5 cents, right?
Yeah. So it says analysis is complete. Reviewer again validated the decision. It approved the decision. It is OSFI compliant. Right now, the confidence also dropped to 95%. Earlier, it was 98%. And we see
Right.
that here in this history. It was 99 actually. So from 99%, it dropped to 95% because we were using a higher reasoning model there. It had more brain power to process.
Right.
It definitely took us more time and cost us more. But this is a low severity alert, and it is auto cleared. Means like the disposition is done. The human doesn't need to review it. The confidence is 95%, which I think is still okay.
Yeah.
Industry standard based on my research is about 85%. And see, it doesn't say any of those things that it said earlier, like review to the agent, freeze
Right.
the account, do this. It said it's a low analyst agent, it's auto cleared, it's approved, so no further action required. And then
Alice, you
in
have a
case of
question?
a medium, it will see, it depends, right? So we can run
Yeah.
a medium as well and see what happens there.
Yeah. While you do that, Alice, you have a question?
Is it the same transaction that you're putting through the three different agents?
No, it's different transactions. So
Yeah, it's
these
categorizing
alerts-
them, Alice, by low, medium, high. So there's a whole pool of transactions, and it's
Oh, I see.
categorizing
I
them
see.
for him, and he's just pulling up what it categorizes as a low, medium, high.
Yeah, okay, got it. I was just checking when he was comparing like the 98 with the 95. I thought that it was the same like transaction, so we can see with the different agents what the difference among the two. But it's okay. I got it. It's a
Yeah,
different
because what he's
transaction.
doing is he's taking it like he's creating like an alert system, right, for a human
Yeah.
to be
Yeah.
pulled into the loop or to clear. And so it's saving, again, he said it would have taken 5 minutes for that high for somebody just to do that manual research checking work, but it took, seconds and like 4 cents
I see.
of a computer's time to do it. But for that one, again, a human has to be in the loop, right, Rahul, to do all those actions for the high one still.
Yeah.
Right. So,
So-
you save time on the front end for the stuff that can be programmatic. But
I see.
for that the other one, you still had to have somebody involved.
Yes. And we just ran the medium one as well. So we can see that it was a little bit faster than the high one, but slower than the low one. And the confidence is 82%. Because again, the data is such that it cannot bring that confidence higher, if you will. And that is why here it's saying contact the customer and assign to a human analyst, because my confidence is not that high.
Right.
And it costs us like 2 cents. So we can also look at it all together here. So we ran 3. So the high one came up with the most confidence. Tokens we used were the most high. Maximum cost there. And then for the low one, it is minimal cost. For the medium one, the confidence is low there because again, it has got mixed information. It has used quite a bit of tokens there, and the cost is higher than the low one.
Right. This is pretty cool, Rahul. And you basically built this because you have that business knowledge and IT knowledge of fraud and the industry and how that works. And, you have some, coding kind of knowledge, but you're able to build this using, tools that are readily available through subscription or open source, right?
Yeah, that is right. And we can also see this live KPI dashboard. So it says that out of the 3 that we ran, 2 were recommended for human reviews. One was like the medium and the other one was high. So we see that, and the auto clear rate is like whatever was done automatically by the low agent. So that's done. And my total cost to run these 3 alerts is about 8 cents. An average
Awesome.
cost is like 2 cents an alert.
Very cool. So does anybody have any questions? I know we're running a little over time, but No, everybody's on mute, or if you're saying something, then you're on mute.
No, I find it really useful. This is just at another level, probably, Jonathan. The only thing
Yeah.
that I feel that there's a lot of value in what he's showing us. I feel that Raul, the word that you find, I find the most value in that orchestrator that you mentioned it.
Mhm.
That's where you build the logic where you're routing all the alerts to the different agents, and all these agents are connected to different models. And
Yeah,
every model, depending on what it is going to be more expensive or less expensive depending on which one you're using.
Well,
right.
and
So,
different quality, right, Ellis? Like some of them
mhm,
will. The reason he's choosing them is because there's no point in using an expensive model when it's going to give you the same result as a lower
the same
model for a
results.
simple task, right? And
Yeah.
that's why we're trying to do in this series is help educate and learn AI. But that we explained kind of what an LLM was. We gave you examples of Copilot. Now we're kind of extrapolating on that or building on that and saying, here's some use cases of where you might use different models. And again, he's using Opus, but he's also using ChatGPT for some stuff. So it's again, you guys all have like a lot of tacit knowledge, and applying that knowledge with these kind of agents, you can help kind of automate some work, but only so much, right? Like Rahul, to do like to go and actually clear and do the human factors. Right now, you have a human in the loop. Maybe with advanced, kind of a reasoning, you could that even those higher level use cases could be automated as well. I don't know.
Yeah, so right now I'm running the same file, like a condensed version of that file in the terminal, so not the
Yep.
UI. And you can see it's kind of processing all the alerts one by one, and then once it's done, it'll create like a, a pretty, not so pretty, but still pretty brief on what it did and how much it costs and so on and so forth.
Yeah,
So it
that's
looks
really
like
cool.
there is one that came not compliant, see?
Mhm.
So it's kind of
I think
processing
I
and
think Ben has his hand up. Rahul, Ben, do you have a
uh,
question?
No, I got a question. I just wanted to speak to that. Ellis brought it up as well, like just asking like what LLM to use for or what model to use for what. And in an agent like this, growing the complexity of it, you may have one model do one thing and then another model do another thing in the same agent.
Yeah.
And you can totally do that just based on the complexity of what that agent is doing and when. So there might be
Mhm.
pieces earlier on. I know I've built agents where, earlier on in the process, I only need very, very simple agents or very simple models, I should say. And, you can go in the Quen direction, for example, and it costs next to nothing. But again, the quality isn't going to be there, but it depends on what you're trying to do. And then later on in the same agent, now you're collecting all this information and producing an output that you absolutely need and it's critical. That's where I would definitely go into a higher model, go into an Opus, go into a 5.5 if you need it, and be willing to pay for it for the outcome to get what you're looking for. So again, it's really kind of determining, and everybody who's building these would need to know what's complex and what's not. And the stuff that's not, go cheap. You may as well.
I think that's what he did here with the haiku. But
Yep.
again, I think Ben, what's interesting is that he brings like what he's got a good example of, and you're expanding on is that when you have to have that business knowledge or that kind of systematic to be able to make it programmatic, right? Like you have to know what's a medium, a high, which one where what situation am I doing something more complex where I might want to use a higher model or a lower model or what the result is. And Rahul kind of said sounds like he tested those out where he kind of tested the A/B testing a little bit, like try to higher model, oh, try to lower one. Oh, the lower one gave the same result as the high, so why would I use a more expensive, right?
And the
But you have to have
confidence
that
level is
knowledge,
as
right?
he's identified, the confidence level is what is critical, right? So that
Yeah,
as you use these agents, they're getting you as close as you possibly can to the the highest confidence level. And again, that's going to be determined by the model that you're using and where. So it's there's some clients that I've worked with and they were looking for a 98% or confidence level. And it's like, okay, well, good luck. It's like,
yeah,
what are you really looking for? And especially this was on the government side, but yeah, I get it. But then there's also, what's your confidence level now, even without AI?
right. Yeah,
And
yeah.
oh, well, reality is it's more than 70%. Okay.
Well,
So
and
anything over
that's kind of
90 is
along the
doing
same lines.
awesome.
It's kind of along the same lines of driverless cars, right? Like the
Hmm.
debate over driverless cars is it better than humans? Some people say it is, some people say it's not. It depends on what statistics you're looking at. In real world scenarios where you're driving in snow or extreme temperatures or this or that, probably not. But in the everyday, it probably is. And so,
Right.
what you have to kind of compare it. I think it's a great point, Ben, to compare it back to your I don't know efficacy today is a
Yeah.
good
Yeah.
benchmark,
Well, because also,
right?
there's a lot of conversation around hallucination. There's a lot of conversation around it's giving me something that's wrong. And you know
Mhm.
what? That's the reality is that's all of us. We've all
Oh
done
yeah,
something incorrect. And it's like, well, that can very easily then get blamed. And I think that's perhaps something that is different about this particular technology versus others that we've used, where, we demand 100% accuracy. And you know what? Like in this case, because a lot of it is just generative, it's not going to be. And that's why we
What?
need the human in the loop to validate what is it actually producing, and we can correct it. Doesn't mean that it's necessarily wrong, but we can also then train it a little bit better as we go too.
It's a great point. And I mean, how many times, I don't know about you, have you kind of told your kid something or told your partner something and realized, oops, actually I was wrong. Like
Yeah.
we're not, we're human. We're fallible too. We remember things wrong. We hallucinate, right? Like it's sometimes people prefer to remember what they want to remember as opposed to, what actually happened, because we don't have perfect memories, just like these AIs don't, right? Like,
Yeah.
so, okay, I think this is great. Rahul, is there anything else you kind of want to cover? Just 'cause I know we're a little over time, and I want to be respectful of everybody's time before we wrap.
Yeah, no, I think that's it. And I just ran it in the terminal because there are a lot of alerts. So it's kind of going through it one by one. It should be done pretty soon. It would just give a pretty table summarizing everything that it did and how much it costs to do that. Again, the cost is just for me so that I can keep track of my usage right now.
Mm-hmm.
That's optional, I would say. But from an organizational perspective, I think there would be some people who would be interested in that.
Oh, yeah.
Yeah.
Well, because you want to compare it to the human cost, right? Like how much time and cost, because there's two factors. One is, to get these results faster, you might be willing to pay more than a human cost. But to get them, at the same as a human cost, you might be okay with it taking or get less than a human speed. You might be willing to pay a lower cost. And that's
Right.
one of the things I think that people sometimes underestimate is speed, right? Like these computers can operate so much faster than human beings in certain things, and often cheaper. But to your point, Rahul, if you let it get out of hand, it could probably pretty quick, or poorly design it. It could cost more than people and provide less quality result.
Yeah, absolutely. And then the other thing is, the objective is not to replace people. I would say the objective is to supplement people with more capacity. So in this case, like my objective is, in case there are medium or low level of fraud alerts, which do not need a person to kind of review it actively or immediately, then that time can be allocated in reviewing the high or the medium severity alerts, where we can spend more time. Because one of the complaints, or not complaints, but one of the things that always come up in my discussions with the financial institutions is that they don't have the operational capacity to work through all the fraud alerts that are generated. And sometimes it could be in like hundreds or even thousands, right? So if I have limited human capacity, I would want to dedicate it to high value or urgent items as opposed to going through like the run of the mill type of alerts, because those fraud controls have got an element of false positives as well, right? So not every alert is a genuine alert. So if we can identify the attributes in that alert and then route it intelligently, we can save human time, which can be dedicated to more critical tasks. So not to replace people, but to supplement them and equip them with more freedom and time to do what needs to be done.
Well, I'm going to play devil's advocate there. I think you are replacing lower functioning people, but you're creating value so that the higher functioning people can be more efficient and rely less on fewer people. But to your point, Rahul, if they don't have the resources to get to the low hanging fruit anyways, this just helps like prioritize, right? And they focus on the 80-20 as of like, maybe they can solve 80% of the fraud with a handful of resources, and that's okay. But to Ben's point, to get to the 99% is, you got to have a small army, because then you have to go in and investigate each one of these smaller ones, which, it probably isn't cost effective for most organizations.
Yep.
That's great. Okay. Anybody else have any other kind of questions or comments in closing, or if you're on mute, we can't hear you? No? Okay. Well, thank you so much, Rahul. This is really cool. And then, maybe we'll follow up with Ellis and we'll do another separate deep dive session, Rahul. Since he's the one that asked for it, maybe we do it more with him rather than with the broader group, but we'll see. Okay. And I think next week, the plan is that Ben's going to talk a little bit about the ethical side of AI, and then we have a use case following another 2 weeks after that. So thanks, everybody, and hope you have a great weekend.
Thanks all.
Thank you.
Thanks, Rahul. Thanks, Ben.
Thank you. Bye.